Okay, here's a couple more forensic techniques. I should mention Yara. And before I talk about Yara, I should talk about Snort, which I haven't included much here in the hands-on projects, although you'll see it if you use those cloud services. Snort was the first popular network IDS system, and what it did was, and still use, Snort has a simple pattern to detect network packets. So you have essentially a grep rule that just looks for a pattern of bytes in traffic, and if it sees that pattern, then it logs information. This type of suspicious packet was found. And it turned out that you had to be pretty skilled to write those rules, because a rule that was too complicated would consume too much CPU, and then it wouldn't be able to keep up with the network traffic. But the Snort rules became the standard format to express patterns of incoming traffic, the early indicators of compromise. And this was quite important. I remember maybe 6 or 8 years ago, I went to a B-Sides conference, and I saw the late great King Tuna from Akamai give a talk, and this was a secret talk. You couldn't record it, and people were, because what was going on was the Al-Qassam cyber army from I think Iran, perhaps, I'm not quite sure what nation, was attacking American banks to punish them because there was a YouTube video that was rude and insulting of Mohammed. And they were in fact not a very skilled attack group, but they were determined to keep attacking until they had done enough harm to American banks to add up to a certain amount of dollars of damage that they calculated. And they had about 30 waves of attacks. And the first few waves of attacks were incredibly simple, like sending HTTP requests that would just try to load pages that had a name that were like 30 or 40 capital A's in a row. So in fact, the defenders found that all they had to do was use Snort with very simple rules, and they could block those attacks. And they tried to sort of communicate this secretly among the banks so that the attackers wouldn't know that they were onto them. And they had so this talk was revealing some of these very simple patterns that were stopping the early phages, and they kept on improving their attack stage after stage to penetrate the defenses. So the defenders were vigorously finding the patterns. And anyway, for a more general thing like files, you use Yara, which is just the file-based version of the same thing. And Yara just lets you define patterns of bytes, and then it will trigger if it finds those patterns of bytes in files. So you make a simple rule like, I can look for anything containing the word evil. That's a simple example. Then you can create some files, one containing good and one containing evil. And when you run Yara, of course, it will detect the bad file. Then you can get Minesweeper, just a common Windows game that I got, and I made a modified version of that, called it MineSam. You can download it, and then you can run Yara on it, and Yara will look for patterns. It will find the file header to tell you what type of file it is, the DIL it uses, and so on. It will analyze files in a simple way, just seeing what structures it can find in those files. So you can scan it, and it will find various information about it. And then you can download more files and look for evil in them. Here's one where you find 3 bytes of 4 in a row, the hex value 4, and so on. There's just you can practice writing simple Yara rules and detecting those patterns in files. And Yara rules are the standard for indicators of compromise, just like Snort rules are the standard for network-based indicators of compromise. So learning how to write this language is a good thing to know. Another useful thing to know about in the world of computer forensics is the Prefetch folder. On Windows servers, the Prefetch folder is disabled by default, because a server is not supposed to be running many applications, and it's not supposed to be rebooting all the time. Typically, a server is just doing one thing, like serving web pages or email, and it stays up for weeks and months at a time. So there isn't an issue of what applications should be loaded into RAM. There's one application loaded into RAM and left there forever. But a desktop machine is the opposite. You open all different programs, you install new programs and games. And so to make it faster for the user, Microsoft implemented the Prefetch folder that will keep track of what applications you have been using recently. And it will after boot up, it will load those programs into RAM even before you click on them, so that they'll load more quickly when you click on them. So this is one of many of Microsoft's performance and convenience features that create a log of what you've been doing. And that means if somebody at your company is running malware or playing games at work or doing whatever they shouldn't be doing, you can look in the Prefetch folder and you will find there a list of the last 128 applications that were launched, when they were launched, and who launched them, which is very valuable forensic information. So to do it, I'm using servers mainly because I was using Windows Cloud machines at this time. So if you're on a server, you have to go into the registry and turn on the Prefetch. It's just a matter of adjusting a couple of registry keys. And then you can launch a few applications like WordPad and Internet Explorer and so on. And you'll see these PF files being created in the Prefetch folder. And those are just little binary files that record information about that application. And it turns out that they aren't easily readable. You have to download PE command, which is a tool that will I think that's the one that lets you see it. Yeah, PE command is one thing that opens up those Prefetch folders so you can see what they did. So you can install OpenOffice and you run the Prefetch analysis and it creates a comma separated value file which you can just open in a spreadsheet like Excel or OpenOffice, and then you'll see a nice list of what file was opened, when it was created, and so on. So this is a useful trick to know in computer forensics, and I've got a challenge here where you find a flag in a file there. So there's a couple things to know about. I'm going to stop this one.